So in this example, our first goal is to create bases that are exactly the same on both sides. Right now they're different. The left-hand side has a base of 36 and the right-hand side has a base of 216. So where do you begin? You always start with a smaller number, which is 36, and you ask yourself, can I use 36 as the new base in order to get 216? And the answer is you can't raise 36 to some power to get 216 because 36 squared is already way higher than 216. So we have to go lower than 36. And you have to make sure if you pick a number lower than 36, you still have to be able to get back to 36. So I could use base 6 because 6 squared is 36. And 6 to the third power gives me 216. So we're going to be using base 6 on both sides. So instead of 36, I'm using base 6, which is 6 squared, to get 36, and that's still raised to the 3x power. Instead of using 216, I'm using 6 to the third power because it's identical to 216, and that's raised to the 2x plus 1. So now that we have like bases, we're going to make sure that we combine these powers here using the power rule, which says multiply them together. So this is 6 raised to the 2 times 3x is 6x, and on the right-hand side, whenever you have two terms and you're multiplying, you do need to distribute. So we're going to be distributing the 3 to both terms. So this would be 6 raised to the 3 times 2x is 6x, and 3 times 1 is 3. Now that we have like bases, all we have to do is set the exponents equal to each other. So I set 6x equal to 6x plus 3. So right now I can already see that this is going to have no solution, because if you have 6x and that's equal to exactly the same but 3 more than that, they're never going to be equal, right? If you want to solve this, you could subtract 6x from both sides, so you get 0 is equal to 3, and 0 is never equal to 3. So in fact, this equation actually has no solution.